Welcome my dear student, how are you? I hope you are all well. So today we learn about electromagnetic induction and Faraday law. I know that you are know about the electromagnetic induction or magnetic flux, but in my channel I will learn you or discuss with you in easiest way. Today my I am ill, so my volume may be something different. So let us start with magnetic flux and electromagnetic induction. So first we can get that what is magnetic flux. Magnetic flux is the total number of magnetic field lines passing through the surface normally. So magnetic flux is the total number of magnetic field lines passing through the surface normally. If we can consider a surface A and magnetic field lines passing normally through it, सरफेस ऐसे है और सरफेस ऐसे है और मैग्नेटिक फील्ड ऑफ लाइन्स इसके साथ परपेंडिकुलर में जा रहा है, तो द एंगल बिटवीन बी एंड ए इज हियर 90 डिग्री. देन द total flux is written as phi or phi b equal to just the product of magnetic field intensity B and area vector A. BA is the total flux of this surface area A. BA, that is magnetic flux equal to magnetic field vector B multiplied by area of the closed surface, area of the surface. It is in uniform magnetic field. In an uniform magnetic field, here we can assume that the magnetic field is same in all the surface. But if the magnetic field lines are not perpendicular to the surface, suppose the surface will be like this type and the magnetic field lines are passing through this direction, this is the surface area A. Here the B is not perpendicular to A, so here we can draw a normal perpendicular to the surface, and here magnetic field intensity is the component of field B along the normal. If the theta is the angle between the normal and magnetic field B, then we know from vector resolution this component of B is B cos theta, the component in which the angle theta inclined is B cos theta and its perpendicular component is B sin theta. Here B sin theta is not get into considered, only B sin theta, the perpendicular component of B. So for any surface in which the magnetic field lines are not perpendicular to B, to the surface, then we can take the normal component of B along the perpendicular direction. Therefore in this case the magnetic field phi B equal to not B but the B cos theta A. So if we arrange it AB or BA cos theta, so we can write it B dot A. What is A? A is called area vector. Its direction A is the area vector, that is a vector perpendicular to the surface area A, and its direction is same as the direction of normal. that is, it is along the outward non-normal direction. So, if the magnetic field lines are perpendicular to the surface, simply BA, and if the magnetic field lines are not perpendicular, then we can take the perpendicular component along the normal B cos theta and the product of area. So, we can get B dot A, and obviously it is a scalar quantity. Now, if the magnetic field is non-uniform, then what can we get? That is, the magnetic field lines changes with time. Here uniform means the total number of magnetic field lines will be equal, but if the magnetic field lines, so for non-uniform magnetic field, let us consider a surface A. Now, if we take a small element dA of this surface, then it can be assumed as uniform. It can be assumed as uniform. The whole surface is not uniform, but if we take a small element, then it is considered to be uniform as it is very small. Then if the magnetic field lines is along this direction and the normal to the surface is n, then we can get the d phi, that is elementary magnetic flux through this surface dA is equal to B dA cos theta or B cos theta dA, that is B dot dA, as we know from the earlier result. Therefore, total magnetic flux we know total magnetic flux B is equal to integration d phi or integration over the total area, that is A, close integration A B dot dA. So, we can get the solution for magnetic flux for uniform and non-uniform magnetic field. Let us go for the unit of magnetic field lines, unit and dimension. Unit CGS and SI. CGS unit of magnetic flux is Maxwell. It is in short it is written as mx, and SI unit is Weber. Now 1 Weber equal to 1 Tesla into 1 meter square. Now 1 Tesla equal to 10 to the power 4 Gauss into 1 meter square equal to 10 to the power 4 centimeter square, that is 10 to the power 8 Gauss centimeter square, or Gauss centimeter square is equal to Maxwell, that is 10 to the power 8 Maxwell. So 1 Weber is equal to 10 to the power 8 Maxwell. In many MCQ question it can be asked that 1 Weber equal to how many Maxwell. So, we can get from this 10 to the power 8 Maxwell. Then next we go for dimension of magnetic flux. Dimension. Phi is equal to B dot A, that is BA. Now, the total magnetic force on a theta, F by QV sin theta, F by QV sin theta. So, Q is Coulomb C, V is L T minus 1, and sin theta is 1. So now, and this Coulomb T minus 1, Coulomb T minus 1 is equal to ampere. Now this L and this L is cancelled, so we can get m L square T minus 2 by this L, this L will be cancelled, C T minus 1 equal to ampere. So finally we can get the dimension of magnetic flux phi is equal to m L square A minus 1 T minus 2. This is the dimension of magnetic flux, m L square A minus 1 T minus 2. I hope you understand it. We can derive the relation of magnetic field, magnetic flux and so many cause. Now we go for the Faraday's laws of experiment or electromagnetic induction. देखिए skip मत करना, don't skip, because very important points we can say in this video. So if you skip, you lost the chance. Stay tuned, देखते रहिए electromagnetic induction. What is electromagnetic induction? Many years ago, Oersted, Ampere, these scientists have discovered that when there is a charge, flow of charge or current, then a magnetic field will occur around it. When charge through a conducting wire is moved, that is, if current is passed through a conducting wire, then magnetic field will be created. The reverse phenomena will be established by two famous scientists in the same time. One is Michael Faraday in England and other is Joseph Henry in USA or America. They said that whenever a magnet is moved to a closed coil or closed loop, current will be induced in this coil. That is, when there is a relative motion, I emphasize the word relative, not motion. If there is a relative motion between the coil and magnet, then a current is induced in this coil. This is known as electromagnetic induction. Now the question arises that how is it possible? When a magnet moves through a closed coil, a current flows through the coil, and if we connect a galvanometer, it shows a reflection. Without touching the coil, a current passes through it. This is the surprise of this electromagnetic induction. How it can be occurred? To answer this question, we can do with an example, but we can go with an example of Michael Faraday. Faraday do many examples, basically three experiment, but here as the video is short, so here we can deal with only one experiment. Number 1, 2, 3 figure. Number 1, this is galvanometer and this is coil, a bar magnet whose north pole is facing towards coil and flux pass through it. Number 2, the same figure, And number 3, this is the basic experiment of Faraday. He observed that when a bar magnet with N pole or north pole facing towards the coil is moving towards the coil with a velocity v, the galvanometer shows deflection towards right. If this is 0 position, it shows deflection from steady 0 to right. But when it is moved away, then the deflection will be reversed. For the first figure, the deflection will towards right, and for second figure, the deflection will be reversed. And for the third figures, when the V equal to 0, that is the bar magnet has in steady position, no current will pass through it, so the galvanometer shows no deflection. Now, what we conclude from this experiment? Whenever the bar magnet comes close to the coil, the number of magnetic fields increases. So, the rate of change of flux increases. As a result, a current induced in this coil which flows through the galvanometer and it shows deflection. But when it is moved away from the coil, the number of magnetic field lines decreases. As a result, current decreases and it shows the reverse deflection. But when there is no relative velocity between the magnet and the coil, because they are steady or goes with same velocity, if these two, that is coil and the magnet will go same velocity, then the relative velocity is 0, or if they steady in one state, then the relative velocity is 0. When there is no relative velocity between these two, no magnetic flux changes. As a result, no EMF is induced and no current flows through the coil, which shows 0 deflection of the galvanometer. From this experiment, Faraday conclude that this phenomena is called electromagnetic induction. What is the form of electromagnetic induction? If we say in one word, electromagnetic induction, in one sentence it is called induced current by magnetism. Induced current by magnetism is called electromagnetic induction. So, Faraday proposed two basic law. What are they? Number 1, when there is a change in magnetic flux, where there is a change in magnetic flux linked with a closed surface, changes and EMF, that is electromotive force, is induced and it lasts so long as there is a change of magnetic flux taking place. when there is a change in magnetic flux linked with a closed surface or circuit, we can know it circuit or surface. When there is a change in magnetic flux linked with a closed circuit, oh দুবার change লেখা, circuit, and EMF is induced and it lasts so long as there is a change of magnetic flux taking place. जितना देर तक मैग्नेटिक फ्लक्स चेंज होता रहेगा उतना देर तक ही ये EMF इंड्यूस्ड होगा और करंट सर्किट में फ्लो होगा. So this is the first law of Faraday. When there is a change in magnetic flux linked with a closed circuit, an EMF is induced and it lasts so long as there is a change of magnetic flux taking place. As soon as the magnetic flux fixed, the current will be stopped. Number 2, which gives the magnitude of induced EMF, which said that the rate of change of the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. When there is the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. This is the second law of Faraday and this is the first law of Faraday. In every book you can find out these two basic law. You can write it from my board or just find in your book and remember it. So what is the mathematical form of Faraday law? The mathematical form is, if E is the induced EMF, then it is directly proportional to d phi dt. E is proportional to d phi dt, where phi is the magnetic flux. Or if the coil has n number of turns, then you can get E equal to n d phi dt. Here we only get the magnitude of induced EMF, but EMF is a vector quantity, it is a force. Then what can be direction? The direction we can find out from the Lenz's law, which we can discuss in the later videos. So I hope आपको अच्छे से समझ आ गया होगा फैराडे लॉ मैग्नेटिक फ्लक्स. और अगर आपको मेरा वीडियो अच्छा लगा तो प्लीज़ नोटिफिकेशन जो बेल आइकन है उसको प्रेस कर दीजिएगा और मेरे चैनल को सब्सक्राइब कीजिएगा. थैंक यू.